Hi, we shall discuss about the conductometric titration between weak acid and strong base, weak acid and weak base, and mixture of acids with strong base. Now earlier we had seen the conductometric titration of strong acid with weak base and strong acid with strong base. Now let us first see the titration of weak acid with strong base, and as an example we shall take up reaction between acetic acid and NaOH. Now this is the experimental setup for the titration. In the beaker you take acetic acid, to that you dip the conductivity cell, connect it to a conductometer, fix a burette having NaOH in it, fix it such a way that we can easily add the base into the acid. Now for all conductometric titration this will be the experimental setup. We would have seen it earlier also. Now initially when acetic acid alone is present, acetic acid will not ionize completely because it is a weak electrolyte, and the conductance if you measure will be very feeble, less, because only a very little amount of H plus ions will be furnished by the acetic acid. When you start adding NaOH, whatever acetic acid is dissociated will react with the NaOH and form sodium acetate, and sodium acetate dissociates. Now remember, Na plus ion and acetate ion have low conductivity. H2O, that is water, will not contribute to the conductivity of the solution. So whatever conductivity of the solution is mainly from H plus ion and OH minus ion. Now let us see what the graph will look like. The plot of conductance versus volume of NaOH will look like for a reaction between weak acid and strong base. Now in the plot you can see initially there is a small dip in the conductance. Now that is because of the feeble ionization of acetic acid. The conductance values come down, and then slowly the conductance value increases because of the conductivity of OH minus ions left after reacting with acetic acid. And also some amount of acetate ion will be present from sodium acetate. And remember, the ionization of acetic acid will be lowered again due to common ion effect. So H plus ions will not be available, and acetic acid will not be available for reaction with NaOH. Now after the equivalence point we find a steep increase in the conductivity. That is because of the OH minus ions from NaOH which is being added after equivalence point. So for all the NaOH ions, NaOH will furnish OH minus ion after equivalence point. Now the intersection of these two arms will give us the volume of NaOH required to neutralize the given amount of acetic acid. Now for all titration, conductometric titration of weak acid with strong base, this will be the pattern of the plot. Now let us see titration between weak acid and weak base. We shall take as an example acetic acid and ammonium hydroxide. Now as earlier seen, this will be the experimental setup for the reaction between acetic acid and ammonium hydroxide. In the beaker you take acetic acid, you dip conductivity cell into it, connect it to a conductometer, fix a burette containing ammonium hydroxide. Now both acetic acid and ammonium hydroxide will not ionize completely, so in the reaction also we'll write in the deionized form, and when acetic acid and ammonium hydroxide react, ammonium acetate will be formed. Now remember, ammonium ion will not and acetate ion has low conductivity. OH minus ion has high conductivity. water does not contribute to the conductivity of the solution. Let's see how the graph will be for the reaction between acetic acid and ammonium hydroxide. We are going to plot conductance against volume of ammonium hydroxide. Now here also, as in the earlier case, we find a small dip in the conductance because of the feeble ionization of acetic acid, and you find that it is similar to the curve obtained earlier for titration between weak acid and strong base. Now later on you find a slight increase in the conductance value which is due to the ionization of ammonium acetate. So whatever ammonium ion and acetate ion is formed after the reaction between acetic acid and ammonium hydroxide will be contributing little to the conductance. Now after the equivalence point, the graph or the conductance values become a constant because of the ammonium hydroxide. Since ammonium hydroxide is a weak electrolyte, it will not conduct much to the conductivity of the electrolyte. So the plot will be of initial dip and then slight increase in the conductance followed by a constant value of conductance. Now this will be the pattern of plot, conductivity plot for conductance versus volume of base for a reaction of weak acid and weak base. Now let us see the conductometric titration of mixture of acid with strong base. Mixture of acid, we are taking a strong acid and a weak acid, and we are going to titrate this mixture against a strong base, NaOH. Now we have initially, when you carry out the titration, the reaction will be mainly between HCl and NaOH, followed by reaction between acetic acid and NaOH. Now this is the experimental setup for the titration. You have mixture of acid, both HCl and acetic acid is taken in the beaker. You are dipping conductivity cell into it. The conductivity cell is connected to a conductometer. Fix a burette having NaOH. Now initially when you measure the conductance of this solution, the conductance will be mainly from HCl because of the H plus ions due to the complete ionization of HCl. So when you carry out the titration, when you add NaOH, the NaOH will be first reacting with all the HCl ions, or HCl, H plus ion and Cl minus. So we can say that the first set of reaction taking place in the titrating mixture will be reaction between HCl and NaOH, followed by reaction between acetic acid and NaOH. Now here also you remember that HCl and NaOH and NaCl ionizes completely, acetic acid do not ionize completely, sodium acetate ionizes completely, H plus and OH minus have got high conductivity, Na plus and Cl minus have got low ionic conductivity, H2O is not going to contribute much to the conductance. Now let us see how the graph will appear. Now as I said earlier, initially the reaction will be between HCl and NaOH. So the initial plot or the initial graph will look like the initial starting arm of a reaction between strong acid and strong base. That is, the conductance values comes down, decreases, steep decrease in the conductance value. That is because you are taking away all the H plus ion present in that Cl by adding NaOH. What you get is NaCl and H2O. Both NaCl, Na plus and Cl minus are not going to contribute much. Even H2O are not going to contribute much to the conductance. So the initial decrease of H plus ion is shown, results in the decrease in the conductance. Now, once all the HCl has been used up, what will remain will be the acetic acid. Now, when you add NaOH, the acetic acid will start reacting. Now the conductance slowly increases. That is because of the acetate ions present, which slightly conducts, and also some amount of OH minus ion of the added NaOH will also be present. So the acetate ions slightly increases the conductivity of the electrolyte. Once all the acetate ion or acetic acid has been neutralized, then again there is a steep increase in the conductance. That is because of the excess NaOH added. All the OH minus ion will be available now for conducting, and there will be a steep increase in the conductance. Now when you take the extrapolate the intersection point of the first two arms, you get the volume of NaOH required to neutralize HCl. And then the second intersection point, the difference between the first intersection point and the second intersection point will give us the volume of NaOH required to neutralize the acetic acid. So from here to here, from the first extrapolation to the second extrapolation, will be the volume of NaOH required to neutralize the given acetic acid. So this will be the pattern for the titration between mixture of acid against a strong base. So go through the video once again, once or twice or thrice. If you have any doubts, do clarify it with me or do clarify it with your teacher. Thank you.